Let's discuss the question number 27 from test 6. This is from strength of materials. The steel prop is used to stabilize a building as shown in the figure. So you have a building where a steel prop is kept. Okay, this is a building. And this is your steel prop. Okay, so now the thing is that the compressive stress in the bar, so already at 20 degrees centigrade it has a compressive stress sigma c, which is 30 MPa. Okay, now the temperature is increased to 35 degrees centigrade. So we are supposed to find out the stresses now. Okay, so what is given is modulus is given E, which is 2 into 10 power 11 Newton per meter square, and alpha, the coefficient of thermal expansion, is given as 14 into 10 power 3 per degree and per degree Celsius. Okay, so now the initial stress is compressive, which is 30 MPa. Now because from 20 to 35 as the delta T is 15 degrees centigrade, this will try to expand, but it is fixed from both sides. So this is something like this. You have it is fixed from both sides, and temperature is changed from 20 to 30. So this will try to expand, but it is not allowed to expand. So there will be stresses that will be set up due to the load that is provided by the building and the ground. So the strain, I mean the thermal strain ET is basically alpha into delta T. So this alpha into delta T is your strain. Let me just write down epsilon T. So this in fact, if the supports are not there, this will try to expand by ET, I mean by delta T. Okay, delta T is basically your L alpha delta T, and your epsilon T is nothing but delta T by L, so which is nothing but L alpha delta T by L, which is L alpha delta T. So this is what I have written for the first time. So now this is what it will expand if there are no supports, but because it is constrained, there will be a forces that acts, and it is compressed by this much amount. Delta C is equal to delta T with the help of this load P, which is set up. So that strain, the compressive strain will be equal to your thermal strain for this rod to be of the same length, and it will be L alpha delta T. So the stresses that are set up due to the temperature will be sigma c dash is nothing but modulus into the thermal strain, which is not allowed to happen. So E into alpha delta T is something, the stresses that is set up in the bar due to fixed, because the bar is fixed and the temperature is increased. So this is compressive because the load P is compressive. Okay, so now the final stresses on this using the superimposition principle is the initial stresses plus your stresses due to expansion. So this is minus 30 because it's compressive, and this also is minus alpha delta T. So this is minus 30 minus E is 2 into 10 power 11 into alpha is 14 into 10 power minus 6, and delta T is 15 Celsius. So this comes out to be, this is E is 2 into 10 power 5, sorry, Newton per mm square. Okay, so this is 2 into 10 power 5, and so I get minus 30 into, So 28 into 15, so this comes out to be 42, and therefore this comes out to be 42, and therefore the total is minus 72 MPa. Remember the E is 2 into 10 power 5 for steel case. Okay, so the answer is minus 72 MPa, and therefore the option is D. Remember both are compressors. Thank you.